then later on you can delete it. Because we don't know what's going to happen here. Might as well keep that going. Because I have no confidence in this machine right now. Okay. Alright guys, let's look at this now. Come on. Okay, so let's expand this a little bit so we have a better picture. Alright. Now we are just focusing on this. What kind of model is this? Have you done something? Cost of equity. Okay, so the LHS in this model, the LHS is the KE. Okay, the cost of equity is the LHS. Okay. Now this model, how was this beta derived? Did you use some particular using what particular technique did you use to estimate the beta? Regression. Okay. So that's what I was getting at. So this is actually a regression based model. Alright, so this is a regression coefficient. So what you did was you took the KE minus RF. You took the KE minus RFs, okay, and you took the RM minus RF, and essentially you regressed the KE minus RF on the RM minus RF, and that's how you arrived at the beta. Does everyone agree? Okay, so this is an example of a model. Okay, now this is an example. Now if I ask you, based on the definition of models that we have studied, 1 minute. So based on the definition of models which we have studied, why is this a model? If I ask you why is the CAPM estimate of beta a model, how will you justify your answer? In the first place, is this a mathematical model?
Yes, sir.
Yes, sir.
Yes. Why is it a mathematical model?
Because it is defining.
1 minute. Yes. Yes, Gaba. Yeah.
Because it is defining the relationship between KE and these variables, between the set of inputs and outputs.
Yeah, but you have missed certain important terms. Specific and mathematical. Okay.
Yes, because
we may not require mathematical, but I'm just putting it in there just to be doubly clear.
specific mathematical variables.
Specific mathematical relationship. Okay. Now, why do I use the word specific mathematical relationship? Because, see, there's a reason why I'm using specific mathematical relationship, because it is, once you specify the model in this form, okay, you can't then go back and say, suppose you don't like the cost of equity estimate that came out, okay, or the beta estimate that came out. You can't, in this case, you can't, if you don't like the cost of equity estimate that came out, you can't then go back and say, okay, now let me add some constant factor here, another constant factor equal to the, you know, expected another variable equal to the expected inflation or something like that. Once you specify the model, there is a certain rigidity involved. Do you understand that?
Yes.
Okay, so once you specify the model, that's why I said it's a specific relationship, and that is also meant to include the word rigid, because mathematical models are all rigid, because once you specify that, you don't have any room for varying. Okay, so this is one thing to learn about this. So now you've understood how to answer the question. Okay, why is this a mathematical model? Because it specifies a precise mathematical relationship, or a specific it defines a specific mathematical relationship between inputs and outputs. This is clear, everyone? It's important to have this theoretical. You might wonder why we are going through such simple things.
Why this is even, relevant in what sense?
We are discussing model. I just want to make sure that everybody understands how to, because you need to be able to think theoretically, okay? Why is this a model? If I ask you to define, everybody should be able to define why it's a model. Okay, I understand it's simple for you, but I'm not sure it's simple for everybody. I just want to make sure that everybody is clear about the theoretical aspect, okay? What is a model? Theoretically, you should have an idea in your head of what exactly a model is, okay? All right, now let's look at some other important concepts. Here in this model, what are you modeling? We are using these expressions. You're doing a course on financial modeling, etc. But there is a particular way the word modeling is used. In this model, if I ask you, what is being modeled?
Some cost of equity.
Cost of equity. Okay, that is the correct answer. If you remember, earlier I asked a different thing about the Gordon Growth model. So Goyal's first answer was not correct. He said dividends are being modeled. Okay, so here in this model, so this is the way this is the way you use the word model. Okay, that is, what are you modeling in this model? You are modeling the cost of equity. Okay, as a function of what are the other variables? RF, RM, and beta. Okay, so this is how you should use the language. So all of this, so this is why I'm going through this, Dipanshu. All this is because everybody needs to be clear how to use the language in the specific way. What is the correct way of talking about these models? Okay, so I just want to make sure that everybody has the lingo and the concepts clear. All right. So therefore now, so this is, you're modeling the KE as a function of the RF, beta, and the RM. Okay. All right. Now here let's learn a few other terms which you now should not have to write. I'm going to just drive.google is going to ask me to log in. No, okay. So let's, I'm going to now just open a sheet which will, open a document which, a page which will, which I will later on put into your folder. So there will go, you don't have to take notes in this, okay. What we are going to start is, okay, let me just. Again, this PC has become slow. I think maybe all the videos that I'm storing on my drive, maybe they're just, see, it's not moving. All right, okay, let's go back to this and let's look at a new term. I'll tell you what you don't need to take notes on, okay? Now tell me, have you heard these words? Okay, here, now stick with the same model, okay? The cost of equity model. What is the forecast variable? There are two other terms you need to know. A forecast variable and an explanatory variable, okay? These are the two, just like we contrast cash markets with derivative markets, okay? We contrast FA with TA, all right? We contrast TAM versus TAM with AM. So another contrast is between, so one contrast is between inputs and outputs. So we are now going to learn a few other terms which are very similar to inputs and outputs. Usually this is all part of your theoretical knowledge about models, okay? I just have to make sure that everybody is aware of these terms. So inputs and outputs you've seen, contrast inputs versus outputs. Now second contrast is between forecast variable. This part you don't need to write. It's there in your notes. It will be there in your notes, okay? You just need to focus on understanding this, okay? So inputs and outputs, and the next thing is forecast variables versus explanatory variables, okay? We're going to understand that. Now in this model, what is the, Kanika, what is the forecast variable in this model? What? Beta is the forecast variable. Anybody else? Sonam? What is the, 1 minute. Sonam, what is the forecast? Is my question clear? Cost of equity. Okay, very good. So Sonam has given the right answer. So cost of equity is the forecast variable. Is everyone clear about this? I hope everybody else is clear. Okay, so forecast variable is more like an input or an output? Sonam? No, I'm only asking her. Okay, Himani. Forecast variable is more like an input or an output? Output. Okay, is this clear? So we are now going to learn a few terms which have the same kind of meaning as inputs and outputs, but we need to be clear about the lingo. Okay, so as we can see, at least one person did not know what is the forecast variable over here. Okay, so here the forecast variable is cost of equity, which is the same as, a forecast variable is the same as output. And what are the explanatory variables? Sushant? In this model, what are the explanatory variables? No idea? Yes? Ishan? What are the explanatory variables in this model? RM, RF, and beta. Okay, so these three are the explanatory variables. Okay, because the value of KE is can also be explained, because remember this is coming out of an elaborate theoretical structure, the CAPM. So this is an example of, just to apply that framework that we have drawn over there. Okay, this would be an example. So this cost of equity model that you've just seen, do you think this it's obviously a mathematical model, okay, but is it only predictive or both predictive and explanatory?
Both predictive.
Nikhil?
Because, sir,
1 minute. What is Nikhil's opinion? Is my question clear? Okay, the first thing is that we can see that the cost of equity model, you have seen this before? Okay, so now this model we are clear is a mathematical model. So we said there are two types possible, either explanatory or both explanatory and predictive, or only explanatory or only predictive. Three types possible, okay? So this is what is the characteristic of this model? Is this only predictive, only explanatory, only or both? Now is my question clear? Okay, well how would you characterize, given that it's a mathematical model, this is what is this? This is explanatory, predictive, or both? Both? Okay, very good. So he's given a correct answer. Everyone should be clear about this. Why? Okay, not just the right answer, but why is it both a predictive and explanatory model? Because remember, it comes out of an elaborate theoretical framework. The whole CAPM analysis, which takes off from the Markowitz risk return, the efficient frontier. You remember all the efficient frontier? Ranking all the portfolios by mean and standard deviation, right? So it comes from there, okay, and there you have the CAPM derivation. So it's a very elaborate theoretical model which tells you why the cost of equity should be a function of this. It's not just mindlessly doing it like in TA. TA, in a way, you can say it's a mindless application, because in TA we are not concerned about why this should be like this. We just say that, okay, because the price has gone over the moving average, now it should go up. Okay, why? If you ask a TA person why, he theoretically should not be able to answer, other than just talking about things like price has gone over the moving average. Okay, but there is no elaborate logical explanation based on rational market. Is clear? All right. So this example, so it's important. That's why I think it's important to go through all these concepts to make sure that your concepts are clear. And this is all stuff that you guys have studied, but now you're able to place it into a particular framework. So this is an example of both both an explanatory and a predictive model. Okay, it is an elaborate explanatory model because the theory tells you why. Because beta, the market, you cannot remember the explanation behind why is it explanatory, because remember all your stuff that you studied, explanatory, your systematic risk, remember all that?
Yes.
Non-systematic risk, okay? Then you don't get rewarded for taking non-systematic risk. Remember all this? Everybody's forgotten all that stuff. Yes? Okay, we have to now open some other files just to deduct some marks. Ridhima and Ria are involved in some detailed calculation. But where is my...
Sir, we were not doing anything.
But you were involved in some calculation, which you are not, and we are, because of which you are not focusing
I
on.
was trying to understand this only.
You're trying to understand what?
Understand what you were saying.
No, you don't try to understand that by going and looking at something on your phone.
So I was listening to you.
No, I saw both of you. I saw Ridhima intently looking at something that on Ria's phone or so, whatever you're holding, book or whatever. Okay. Now that we have this up, we will have more aggressive deductions. Okay.
Sir, I've been holding my register only. Yes, sir.
Yes, sir.
Sir, seriously.
Just, I've already told you 1 minute. Why are you holding your register? I've told you guys, everybody's face.
Because I was trying to understand the point.
No, 1 minute. Everybody's face needs to be turned to me. Simple as that. Okay, it's a very difficult thing to do, I understand. But for the last 10 sessions left in this class, because there's too many people who are switching off and playing their own games, which Sahil.
Yes, sir, I have.
1 minute. Now just look at me now. Everybody should look at me. Okay, whenever I see anybody, I should see their face. I don't want to see anybody's face looking down. Okay, is everyone clear?
Yes, sir.
I was looking at my register only.
1 minute. Don't look at your register. Why do you need to look at your register? It's so dark over there, you can't even read anything.
No, sir, I can.
1 minute. No, 1 minute. You can't even look at anything because it's so dark over there. Don't look at your register, don't look at your phone. Okay? Another here, Akshit also, I'm going to deduct marks because Akshit is also looking at his phone. Akshit is in which team? Akshit, come and put your phone over here so you don't make this mistake. Come and put it here. Put the phone over here. Put the phone here. Akshit is in which team? GABA. No, where is Akshit? Okay. Tanvi's team was the highest scorer in the previous course. Okay. Everybody should be looking at me, okay? That's the...
From Ria group also.
Sorry? Which is... Oh, Ria is not the same group.
No.
Okay. I thought Ria was the same group. 1 minute. Where is Ria? So I didn't even know this. I thought Ria was a part of, because she's always hanging out with you guys. Okay. Okay, guys, one sec. See, I know, 1 minute. This is a postgraduate program. We are wasting all this stupid time having to deduct marks because you guys are not focusing, okay? If I can be ruining my throat, shouting at the top of my voice for the 1.5 hours, the least you guys can do is look at me all the time. Be engaged with whatever is being discussed in the class, okay? I don't want to see anybody looking down, all right? All right, okay. So now what did we cover? We covered explanatory variables and forecast variables, okay? So you understand, it's also important to understand why exactly the CAPM is an explanatory is also an explanatory model. It's not just a predictive model, it's also an explanatory model. That should be clear to you in your head, okay? Because it explains why, because of all this systematic, non-systematic risk and all that stuff, why it explains exactly why the cost of equity should be written like this, okay? Is this clear? Okay, so if every time you have a problem, then you ask me, okay? Now it's also a predictive model because it also shows you that you can actually estimate values for the other three, for the three inputs, okay? And you can make a prediction for what the cost of equity will be. So it is also a predictive model because it's telling you what the cost of equity will be, okay? If these variables have certain values. Is everyone clear about this? Okay, so we have now learned inputs, outputs, forecast variables versus explanatory variables. Okay, one more set of distinctions: endogenous versus exogenous variables. Who will tell us? Ria will tell us. What is 1 minute? Be careful about the terms. Endogenous and exogenous. All this is written here in your notes. You don't have to write down. It will all be written in your notes. Endogenous versus exogenous. Who will tell us? Double A. Any idea? In the same model, what are the endogenous variables and what are the exogenous variables? Have you heard these terms before?
No, sir.
Nobody? Dipangshu? No? Dharam? Yes, but Behel, why don't you try? You can always try because I'm not going to shoot you if you get it wrong, okay? Yes, Behel, what is the answer?
Endogenous variables are those variables which do not get affected by external factors or forces, whereas exogenous are the vice versa.
Okay, I heard your answer. Yes. Anybody else? Yes.
Internal factors and
Internal and external. Okay. So the answer is not correct, but at least you've got one part correct. Both Achal and Behel have got one part. Sahil, you want to answer?
Sir, the endogenous variables have origin from inside.
Have originated from inside. So can you expand? Can you take that idea a little bit further? In this model, what originates from inside? In this model, so his answer is not bad. His answer is actually correct. Endogenous variables, which are those not very elegantly expressed, but it's correct. That in the idea is correct that it is something which originates from inside. So my next question is, in this model, yes? 1 minute. Everyone else be quiet so I can listen to him. In this model, what originates from inside? K. Very good. Okay. So without being elegant in his expression, he has actually between them they have figured it out. So even Behel and Achal have given partially correct answers because at least they were able to understand that endo means inside and exo means outside. Okay. So endogenous and exogenous means supplied from inside and supplied from outside. Okay. So and then Sahil has taken it to the next few steps to the right answer. That endogenous variable essentially is a variable whose value is sort of derived, okay, is derived or determined, okay, within the model. Okay, it is determined within the model. Okay, so remember now if you talk about endogenous and exogenous and you compare them, remember these three distinctions are all similar: input versus output, forecast versus explanatory variable, forecast variable, and then endogenous versus exogenous. Now between endogenous and exogenous, which do you think is likely to be the input? Is my question clear? I said these terms are all similar.
It will be the RF, beta and RF.
Okay, 1 minute. Let me just repeat the question once again for everybody. Some of you have already got the question. I said that these three terms are all similar: input versus output, forecast versus explanatory variable, and the last is endogenous versus exogenous. So now my question is, in the case of exogenous variables, is it more likely to be input or output? Who is saying input and who is saying output? Shivam is saying input. Okay, and who is saying output? The question is, you understood these three sets of terms. Now I am asking you, exogenous variable, is it more likely to be an input or an output? Output. Ishan is saying output, and next to him Shivam is saying input. Okay, anybody else with different views? Dipanshu? Output. Input. Okay, so there seems to be a slightly greater number of people saying input, so that is actually correct. Okay, exogenous is input, because exogenous is, think of this like, suppose this is the model. Okay, you are taking the exogenous variables and you're kind of shoving it into the model, and then you're pressing some button and telling the model, now you give me the output. Okay, so exogenous, why is it called so if you remember, like Achal and Bell got that part right initially, I'm sure he also got it right, that exo means from outside, endo means from within. Okay, so exogenous, we have to remember exo means outside, so then you remember, so if you remember this realize this is a model, you are shoving the exogenous variables into the model from outside. Okay, you're taking some values of, you have already estimated a value of beta, you're putting that into the model, you've got a value of RM, you got a value of RF, now you put all those inputs into the model, okay, and then you press a button and ask the model to give you the output. Is this clear? Is everyone understanding? Because you need to have this kind of basic understanding of theoretical understanding of models, so that later on you'll be able to detect models when you see them. You'll be able to see the form of the model. Yes, Ishan?
But endogenous are dependent variables.
Endogenous are?
Dependent variables.
Yes, okay. So Ishan has actually brought us to the next set of distinctions. Okay. So Ishan is saying endogenous variables are dependent variables. Okay, so we'll come to that at the next stage. Let me make sure that everybody has understood this here. Okay, but you're actually moving a few steps ahead. Okay, so 1 minute. So we will have 4 sets of distinctions. Okay, but let's make sure before we move on from here, everybody make sure you understand this. Okay, it is meant to clear your concepts. Basic concepts about models or the way you think about them. Okay, so endogenous, exogenous, now everybody has understood exogenous models. Visualize a model like a black box or something. Okay, need not be always, just think of it as a box. Some of them may be black box models. Into the box you enter some inputs which are exogenous because they're coming from outside. Then you press a button and then the model calculates and gives you the output, which is the forecast variable. Okay, which is also the endogenous variable. Why is it called endogenous? Because it's inside. Endo means inside, because the value of the output is determined inside the model by the structure of the model. Here the model has this particular structure. You can see in this structure there is no natural logarithm or there is no square root expression or anything like that. This model has a particular type of structure. So depending on the structure of the model, the inputs will lead to certain type of output. Now if I change this formula and put in some natural logarithm of beta and then square root of Rm, then the output will be different. Is that correct?
Yes, sir.
By changing the specification, I will have a different type of output. So again, that will still remain an endogenous variable, but will have a different type of value because the model structure will lead to a different output. So everyone clear about this? Exogenous, endogenous? Is everyone clear? Okay. So exogenous variables is the same as inputs. Endogenous variables the same as outputs. Okay. Which has exogenous is more like a forecast variable or an explanatory variable? Exogenous. Exogenous is pairing with explanatory variables. Okay, we'll have 4 sides of discussion: input versus output, forecast versus explanatory, endogenous versus exogenous, and the 4th one which Ishan has pointed us to. Now he's talking about independent versus dependent. Okay, so Keshav, in this model, which is the dependent variable? 1 minute, I'm asking Keshav. Is the question clear?
Yes, sir.
Oh, K is the dependent variable? Okay. Anybody else with a different view? Okay. So he's right. So KE is the dependent variable. Okay, because the value of KE is dependent on the values of these other 3 inputs and the structure of the model. Okay. But the value of RM, a value of RF are exogenously supplied. So they are not dependent in any way. They are independent variables. Okay. So is this clear in this model? So these three are independent variables. Is everyone following? Jen, are you following? Okay, what are the three independent variables in the RF model? In this KE model? Yes? RF? Beta, RM and RF. Okay? Alright, so you need to wake up a little bit, I think. Alright, okay. So is everyone clear about this? Okay, we covered dependent and independent already. Okay, so all these are there in your notes. Okay, you'll get the notes. You'll see everything is written there. You don't. But we need to remember these four sets of distinctions. Okay, so is this giving you a slightly better perspective?
Yes.
sir.
Okay, you need to have this theoretical understanding so that next tomorrow, if you see some new type of model, you should be able to place it in a structure that okay, these are the independent variables, etc. Whether this is explanatory or predictive or whatever. Okay, all right. Okay, so now let's quickly do another. Quickly do another example of project IRR. Okay, I don't need to do project IRR from here. Actually, I can just do it from here. I want to do this. I want to quickly do this exercise so that we have. What happened here? Okay, now at least the PC is functioning. I have a feeling this might be due to the new Firefox. We'll find out. Firefox is supposed to be such a high-end browser. I don't know why it's considered technologically. It's considered much more sophisticated than Chrome. But somehow it's always giving problems. For the last two versions, it's giving problems. Firefox is supposed to be the best browser. Technology in terms of geeks, if you ask the tech geeks, they will tell you that Firefox is the best browser. But I don't know why this is happening here. Obviously, it's not holding up. On my control end. Let's go to the end. Why is this? They've been released early. Why are they screaming? Okay, guys. Now one sec. This blue material is there in your under the capital raising module. For those of you who want to learn, this is not part of your syllabus. Okay, because I didn't want to have time to cover. I didn't have time to cover it. But it's important to learn. And if you want to be a serious finance student, you should read this material. Okay, it's an IMF material on securitization. It's very closely collected. Read this in conjunction with your chapter 8 of the Hull Basu, which deals with the GFC. Okay, so this is very intimately connected to the GFC. Alright, now let's go back to the YTM and quickly do these exercises once again. Okay, Solanki, in the YTM model, which is the endogenous variable? We don't need to do project IRR, because IRR and the YTM are the same. In the YTM model, which is the endogenous variable? Is my question clear? Quiet, we have some noise at on the outside, so we need to be more careful here. Yes, testing. Not clear, Dipanshu. So now you can see why I'm going through all this. Many people are not clear about these simple concepts. You need to, the theoretical understanding needs to be clear. Bond price is the endogenous variable. Okay, anybody with a different view? Parmeet? Bond price is the endogenous variable? Everybody? Mansi is also nodding. Sina? Bond price is the endogenous variable? Yes. AA2. Bond price. YTM is the endogenous variable. That is the right answer. Okay. So here you do not see the bond price does not need to be determined because this is what is this a market price or the fair value? This is the market price of the bond. You don't need a model to find out the market price of the bond. You can just check a Reuters or a Bloomberg quote page and find out the market price of the bond. Okay. So the bond price is not the endogenous variable here. In this model, remember, which is the same as your project IRR. So every time you see a YTM formula next time, you should be able to put into this bond price block, into the same slot, you should be able to put the what? The cost of the project. Is this clear? Every time you see this now, next time you should mentally do the exercise. Replace the bond price with the cost of the project. Replace the bond cash flows with the returns from the project, right? And replace the bond YTM with the project IRR. Is this clear? Is this the exercise we did in the previous class or some classes ago? We did this exercise. that they are exactly the same. Mathematically, there is no difference between project IRR and bond YTM. Okay, if you take the cost of the project, which is very reasonable, there's nothing to even say here. The cost of the project is conceptually equal to the bond price, because the bond price is what you have to pay to invest in the bond. Okay, so and the cost of the project is what you have to pay to invest in the project. The returns from the project are the same as the bond cash flows. What happened? Everybody is falling asleep. I'm not getting a good enough response. Yes, yeah. Please say that. Like a military conference, a military parade or something like that. Okay. So I need to get a strong response. Okay. All right. So everybody, so please be clear now. This is why I wanted to test this. See, this is why I wanted to bring this up and test the concepts. Okay. Here the endogenous variable is the YTM. Okay. This is what. So here in the YTM. So remember in the YTM equation. Okay. Again, AA2. Which team are you from? AA2 is engaged in some discussion with Himani.
I was not talking, sir.
Who cares if you're talking? I want to see, if I see any kind of engagement in any other activity other than listening to me, I'll deduct marks, okay? Where is your Himani's team? Himani is the leader?
Rahul stays. Rahul.
So much time is wasted doing all this. 1 minute. Okay, we have these are all important concepts which you need to cover. I need to make sure that you understand this. Okay, so is everyone clear now that in this model, these are all important concepts. In this model, the endogenous variable is the YTM. Okay, so in this model, what are you modeling? So learn this as a thumb rule. Okay. Whenever because now we are using the English language, that also has to be used properly. Okay, I am modeling the value of a stock, I am modeling the value of a junk bond. Okay, similarly here you are modeling the YTM. Okay, so as a thumb rule you can remember that when you want to use this English expression, I am modeling this, I am modeling that. What you are modeling is always the output or the dependent variable or the forecast variable or the endogenous variable. This is clear? All these are equivalent. Output, forecast variable, dependent variable and endogenous variable. Are you following what I'm doing here mentally? Okay, there are 4 sets of distinctions. Output is equal to forecast variable is equal to dependent variable is equal to endogenous variable. Is everyone clear about this? Okay, all of this is in your notes, you should revise it. But you should make sure that your concepts are clear. Everyone should go back and revise and quickly and make sure you understand this will help you. If you do this exercise, your concepts will become clear. Next time you detect somebody shows you another model, okay, you will be able to break up the model into all these components. Okay, so in this model, what you are modeling is the YTM as a function of what? Again, English language description of model. As a function of cash flows, fine. The CIs, CI, C1, C1, C2, and the P is also part of the C. I mean, essentially the returns from the bond. Okay, you are modeling the YTM as a result of as a function of C's and what else? Bond price. Don't forget that. Okay. So here, what are the exogenous variables in this equation? Bond price and the returns from the bond, and the returns from the bond are both P and I. This is the P and these are the I's. Okay, and there is a bullet repayment of principal. Okay, so just like this, in the case of project, how will you describe P? What is the equivalent of P? You've done project valuation? P. Now this P, what is the nearest equivalent in project analysis? Is my question clear? When you write this in project form, in the project cash flows, when you write there is a lump sum payment at the end, which is different from the regular cash flows. What is that? Salvage value. You heard of the salvage value or the terminal value when you do it for stocks. So in projects you will have something called salvage value. Then you sell off the project and get, that is conceptually equivalent to the principal repayment. Can you see that?
Yes.
Okay, so these are all the same. So next time you see this, what you're doing here in this equation, you're modeling the YTM as a function of bond price plus returns from the bond. which consist of both P and I, both principal and interest. Okay, is this clear? Okay, now if we do this, where are we now? 10:59. Okay. Oh, the V clock has also disappeared. Okay. All right. So we'll let you go. We'll see this clock. Okay, fine. So we have 1 minute left. So is this clear? 10:59:40. So I hope you guys have learned something today. Okay. So please go and revise all this. Make sure your concepts are clear. And then next class we'll discuss NPV again. We'll just revise all this to make sure that then we'll go on to other stuff. Okay. So please remember, this next week is your trading in equities. Okay, just practice buying calls and puts right now, just based on your assessment of the underlying asset. If you think that G is going up, you buy calls. If you think it's going down, you buy puts, or you sell calls, sell puts accordingly. Okay, we'll deal with the frameworks.